Welcome everybody. This is going to be my video on section 5.3 on slanted asymptote. So as you can see, I'm using a better technology now because I was able to, I guess, purchase all the stuff because my sugar mommy bought me all the good stuff. But nonetheless, we'll talk about that another time. Let's go ahead and begin. So today, as I said, I want to work on section 4.3, which is on diagonal asymptotes. And what we'll do first is we'll look at an example of something that we did last semester. So here you can see the equation y is equal to x plus 1 over x. And what I did was I actually graphed it on the side over here on the right. So this is just kind of like a recap again of what we did last time. Well, long time ago actually. So in the red, the graph right here on the red, that's going to be the line y is equal to x, and the graph that is in green, that is going to be the equation y is equal to 1 over x. So I basically graphed each one independently. And you'll notice that there is a third graph, which is in the color fuchsia. That is right there. That's going to be our final curve. Now, the question is, well, how do you actually get that curve right there from the first curve being the red one and then the second curve being the green one? Well, what we did from last semester is that we basically added piece by piece, using our fingers in order to figure out what the graph actually looks like. So, for example, over here, looking at when x is equal to 1, oops, sorry about that. Let me just go ahead and change that up. We're going to look at what happens when x is equal to 1. For when x is equal to 1, we can go ahead and plug it into each equation. So then that means the first part, you're going to get 1 is equal to x plus 1 over 1. So the answer is equal to 2. So that's basically where this point is actually coming from. So in essence, what we did was we took the two y values over here, added together, and that's where we get that single point. Now, if we want to move on to when x is equal to 2, we can do exactly the same thing. But here's what I'm recommending then. If you remember, what we did last semester was we said, okay, well, look at the y value over here for the red, which is over here. Look at the y value for the other curve, 1 over x, which is over here. And we're going to take this small little amount right here, and we're going to just go ahead and add it to the y value over here, and that's where we get this point that's over here. And as we keep going, we can go ahead and see at x is equal to 3. This is going to be y value of 3. We take this small little increment, and then we're going to go ahead and put it over here, and that's where we get this point on the curve. So you can see now that's going to be kind of like the rough sketch of what the graph actually looks like. But another way of looking at this to make this a little bit easier for this section is that the line y is equal to x, the first equation over here, that's really just kind of like a new x-axis where you're graphing the second equation on it. Just kind of like, drawing it out for you. Here is your original x-axis and y-axis. Imagine if I go ahead and introduce the line y is equal to x, right? So that's going to be this guy over here. That's going to be my new x-axis because that's what's happening on this graph. And if you notice, the graph of y is equal to 1 over x normally looks something like this. Well, imagine now this graph where the x-axis is rotated by 45 degrees so that it looks something like this then. You're just going to graph this equation onto this graph over here. So the result is that is what we're going to get over there on the right-hand side. So the idea behind it is that we basically have two equations where we're trying to add them together or subtract them from each other, where we treat the first one as an x-axis, and the second one is basically what we're going to graph on, and that's why we call this section the slanted asymptote. So let's go ahead and take a look at another example to give you like another hopefully you can see a little bit better. Let's say we have y is equal to x minus sine of pi x over 2. Now again, what I did was I graphed each one individually. Y is equal to x. That's going to be in the blue, in the green. The equation sine of pi over pi x over 2. That's going to be on the red, and that's over here. So what I'll do now is I'm going to go ahead and try to graph the combination of the two together. And you'll note that this is going to be a little trickier than the first one because of the subtraction sign that's over here. So what that means is you're going to have to subtract one equation from the other. So let's start at x is equal to 0 over here. The y values are going to be the same, which is 0 minus 0. So the answer, or the sum of the two, or the difference of the two, is just going to be at the origin. Now, when you get to x is equal to 1, if you take 1, which is the y value on the x graph, and then you subtract the 1 that's from the y value of the red graph, the difference of the two y value, well, that's going to be over here. Moving over along to when x is equal to 2, I'm going to take the y value that's over here at 2, and then subtract the y value that's over here, that's a 0. So 2 minus 0 is going to be equal to 2. So then you can see that this point is located here, and then you have this point that's located here, and then you have this point that's located here. A couple more times until you actually see the graph. The y value over here is at 3. The y value over here is going to be -1. So when you take 3 minus -1, then that is going to give you 4. So that is going to be over here then. Okay, because remember, this part is going to be negative at x is equal to 3, and you're supposed to subtract it, so that's why it's moving upward instead. And this final part right here for when x is equal to 4, we are going to take the y value over here at 4, subtract the y value that's over here at 0, so 4 minus 0 is just going to be, again, on the axis over here, on the line y is equal to x. If I were to connect the dots, this is basically what it will look like then. So here you can see if I connect it, you'll create a curve. And that is going to be the result of the two graphs combined together because of the subtraction. Now, we could go over here and do the other side too, but I think you get the idea as to what's going to happen then. At x equals to -1, just to give you an idea, y is equal to -1 for the green graph, and then y is equal to -1 for the for the red graph. So -1 minus -1, that's going to be -2, so that's going to be down here. Then at x is equal to -2, we have -2 over here for the y value, minus 0, so that's going to be just back on here. And then for x equal to -3, that is going to be -3 minus 1. So that is going to give you -4, that's over here. And I think I made a small little mistake because actually at x equals to -1, when you have -1 minus -1, that's actually 0. So I do apologize for that. Let me go ahead and make the small little erasure right here. Okay. And now we're going to go back and continue on. Oops, actually, you're going to have to excuse me because I need to kind of draw this back here and draw this back here just so that it looks a little bit prettier. Okay, but now going back to what we were saying, let's see, there we go. Okay, if I were to connect the dots, then you can see on the other side, here's what it looks like then. From this point to this point, you're going to make a curve, and then you're going to make a curve, and then you're going to make a curve, and then you're going to make a curve. And as I was saying earlier, as it turns out, what's happening is for the line y is equal to x over here, that is really kind of like saying the new x-axis right here. Okay, so that's right there. That's kind of like our new x-axis. Okay, whereas for the other graph, y is equal to sine of pi x over 2. We basically graph along the new x-axis, so that's why you can see the graph is actually going to be slanted. Okay, so now that that's out of the way, let's go ahead and try to apply this to one of the problems that we have in the homework assignment. What I did was I said, let's go ahead and take number 12 over here because this one looks pretty difficult and it's something that's not in the back of the book because, you know, we, for some reason, the author doesn't do with multiples of 3s for answers. Okay, so here, let's go ahead and go to this page over here, and there's our example. Okay, so what I would like to do is graph that equation according to what we just learned earlier. So first, let's go ahead and isolate y because we need to clean up this equation a little bit. So let's go ahead and do that. Let me go ahead and change it back to this pen. Okay, here we go. So let's go ahead and isolate all the y terms. So here's one, and then here's another one. We can go ahead and leave those on the left-hand side. So that's x squared minus 4x, and then plus 4. Hey, look at that. It's a perfect square, so that kind of works out nicely. All multiplied by y, because we're going to factor out from each term, is going to be equal to everything else. We're going to move over to the right-hand side. So that's x cubed minus 11x, and then plus 16. Once we have y all by itself factored out, we're going to go ahead and take this guy over here and divide through to the right-hand side. So y is equal to x cubed minus 11x plus 16, all divided by x squared minus 4x plus 2. And earlier I mentioned that this is a perfect square over here, but I didn't actually factor it because we actually have to use long division in order to clean up and see what this is actually going to come out to be. So let's go ahead and do that on the side over here. So we have x squared minus 4x plus 4, and we're going to take that let's see, take x cubed minus, plus 0x squared minus 11x plus 16, and divided by this factor of x squared minus 4x plus 4. And you'll note that I did actually put in an extra 0x squared because that term is necessary in order for me to do the long division. Okay, so here we go. First, we're going to go ahead and write x over here on the top, because when x is multiplied by the factor of x squared minus 4x plus 4, the result is that you're going to get x cubed minus 4x squared and then plus 4x. And I want that there because I'm going to take the whole thing and subtract it. So this is a long division problem that hopefully you guys remember how to do, because we had to do it in the previous section also. So x cubes cancel out. The x squared terms, that's going to give you 4x squared because it's negative and negative. That makes it positive. And for the x term, negative 11x minus 4x, that's going to be minus 15x. And we're going to go ahead and bring down the plus 16. Now we're going to find something when multiplied by x squared that would give us the 4x squared. And that something would then be a 4. So that's where we're going to go ahead and subtract then. That's what we're going to put on top then. So 4 times x squared, so that's 4x squared. And then we have minus 16x, and then we have plus 16. Take that whole thing and subtract it. And again, remember, make sure you write the parentheses in there. So 4x squares goes away, 15x negative, and then plus 16x, that's going to be leaving you a single x. And the 16s cancel out, so that works out nicely. So then usually at this point, we basically say that this is going to give us x plus 4, and then plus the remainder, which is going to be x divided by this x squared minus 4x plus 4 thing. So that's going to be our y then. Okay, so our our equation is going to be y is equal to x plus 4. And then we have plus x over. Now let's go ahead and put it into the factored form. So then we can actually figure out what this graph actually looks like. Okay. We have our equation, and in terms of what the graph actually looks like, remember what we just said. The first part of the equation, which is something that's nice and clean, that's going to be our slanted asymptote or diagonal asymptotes, whereas the second equation, that's basically what we're going to graph. So here, let me just go ahead and graph each one individually so you can see what's happening. Okay, and in fact, let me go ahead and change the color so then that way we can see the difference between the two. So let me go ahead and get rid of this guy. Let me get rid of this guy. Let's say that this graph right here, let's say that this equation is going to be in red, whereas the second equation right there, that is going to be in blue. Okay, so that's going to be this guy over here. Okay, so let's go ahead and graph each one individually. So let's see, let's go ahead and draw an axis first. Okay, so here is my axis. Okay, so much nicer so that I can write on this because I can't really draw a straight line for worth anything. Okay, so here we go. X plus 4, the graph of that's not too bad. We all know what that actually looks like. In fact, you know what? Let me actually make a small little modification if it's okay with you guys. I'm going to go ahead and lower this graph because of my equation y is equal to x plus 4, since I know that it's supposed to be a little bit higher. All right, so let's see, back to this. So that looks okay. So here, let me go ahead and make it lower, like say over here, okay? All right, so as I was saying, y is equal to x plus 4. That is supposed to be in red, so I'm going to go ahead and draw that. And remember, that is going to be our diagonal asymptote, or kind of like the x-axis. So what I'll do is I'll go ahead and draw it on a perforated line, like so, okay? So then that way you can kind of see that right there. So that's y is equal to x plus 4. Okay, for the other equation, y is equal to x over x minus 2 quantity squared. This guy, we know the following characteristics because we did it earlier. And by earlier, I mean like in the last section. We have a 0 located at x is equal to 0, meaning that's where it crosses the x-axis. We have a vertical asymptote, or as I call it, the end behavior. And in fact, I really should actually just go ahead and say end behavior right now. So EB for end behavior. And that's looking at what happens when x becomes a really, really large value. Because the denominator has a polynomial that's larger than the numerator, so then that means that the bottom is going to get to infinity a lot faster than the top, and hence the graph y is equal to 0 is going to be its end behavior, meaning the x-axis. And then we also have a vertical asymptote located at x equals to 2. So again, you know, if I were just to graph this on the side, this is basically what it looks like. And I know I'm not using the axes, so you have to excuse me. So here's x, and then here's y, 0 at x equals 0, so that's located over here. The vertical asymptote at x is equal to 2, so that means like somewhere over here, you have a vertical asymptote, okay? And then the end behavior is y is equal to 0. We can then figure out what the graph looks like by figuring out in which interval is it going to be positive or negative. So for example, let's go ahead and look into this interval over here to see what's happening. Let's try to plug in x is equal to 1 into the equation. So when I plug x is equal to 1 to the equation, we get 1 divided by 1 minus 2 quantity squared, which is going to give us 1 over 1, which is a positive number. So that tells me that whatever I'm graphing within the interval of 0 to 2, it's going to be positive. So graphically, then that means you're going to start at the 0, you're going to go to 1, right? At x is equal to 1, you get y is equal to 1. And because you have a vertical asymptote, then that means that the graph should do something like this. After any vertical asymptote, you are going to usually end up on the other side, meaning on the bottom of the vertical asymptote, meaning somewhere down here. But because of the squared factor, then that means you actually end up going down from the positive infinity part because there's actually no sign change there. If you want to verify that, you can actually create a plus or minus chart just like we did in the last section in order to make sure of that. The last part is a little bit tricky because when you have x less than 0, remember everything is supposed to alternate in sign. So this is going to be positive. This is going to be positive because of the x minus 2 quantity squared. This is going to be negative. So the question is, well, how do you draw the portion of the graph that starts at 0? Everything is negative and it's going to go towards 0. Well, the graph would actually have to go dip down and then come back up to something like this. Okay, so if you're having a little trouble with what the graph actually looks like for here, I recommend you go back to the last section just to take a look. Nonetheless, now we need to take this guy and implement that into our equation over here so you can see what the new graph actually looks like. Remember, this graph right here that we just drew, that's what it's supposed to look like. But because of the x plus 4 that we have to add on to the equation, keep in mind the x plus 4 is really just our new diagonal axis, the new x-axis. So if you can imagine what we just drew, we take the x-axis and then we kind of like rotate it by 45 degrees and we shift it up by 4 units. Okay, so again, the red right here, the perforated line, that is going to be our new x-axis. Okay, and so if we combine the two equations together, this should be the end result then. Okay. The vertical asymptote is at x equals to 2. Okay, so that's not going to change. So that means that you still have this guy over here. Okay, so let me go ahead and draw that in. Let's see. Now we're going to go ahead and draw the rest of the graph. Here in my blue graph, we hit the origin at 0, 0. So that means in our new graph, you're going to hit the origin, which is located right here. And the rest of the graph, well, we can just kind of follow what we have here then. So this part is going to go up this way, and then it's going to come down this way, just like what we have over here on the right-hand side. And for this part, we're going to go ahead and dip down, just like we did on the other graph, and then come back up. So then that way it gets closer and closer to the x-axis, which is diagonal in this case. So this right here, that's going to be our final graph then. It's not exactly the nicest graph, but hopefully you get the idea of what's happening. Okay. All right. So let's look at our final example of this. Okay. And this is going to be, I guess, the harder case then. So this is now what I want to graph. Graph the following relation. And I know this is a relation because you can see x and y are basically on the same side of the equation, and you have a bunch of x, you have a bunch of y. It's not going to come out nice for the most part. Okay, let's try to translate what's actually happening here so you can get a better idea as to how to graph this. We have 4 parts to this equation. We have this factor. Actually, let's go ahead and change this. Okay, there we go. Once again, we have 1 factor, we have 2nd factor, we have 3rd factor, we have 4th factor. Anytime you have something like this and you want to solve for x, what we normally do is we set each factor equal to 0 because of the 0 factor property. So let's go ahead and try to see what's actually happening for each part. The first equation, or the first factor, we have x squared plus y squared minus 25 is equal to 0. That has to be true because, remember, again, of the 0 factor property. If we clean up this equation a little bit, this might look a little bit more familiar to you. That's x squared plus y squared is equal to 25. And this tells me that the graph that I'm trying to graph right here, this is going to be a circle of radius of 5 at, with center. Let's see, actually, let me kind of change that a little bit. Let me erase this guy right here so I can write it correctly. With the center at 0, 0. Okay. So what's happening is we actually have a graph that consists of 4 graphs put together because they are all part of, they're all factors of this big nasty relation. Let's go ahead and translate each one then to see what happens next. The second factor over here, again, we have y plus 2 minus the square root of 4 minus x squared is equal to 0. Again, taking this factor, go ahead and set it equal to 0. Now, if I move the square root to the other side, so then that way, you know, I can try to solve for y because usually that's the best way to figure out what the graph looks like. Here's what you'll get. Y plus 2 is equal to the square root of 4 minus x squared. We have then y plus 2 quantity squared is equal to 4 minus x squared. And if I move the x squared to the other side, you'll notice that it looks a little bit more familiar to you as well. This is going to be a circle that is going to be the same idea. The circle with a radius of 2 with the center at the point 0, negative 2. Now, you'll notice the equation for this first factor and the second factor, they're written a little bit differently. And that's because they are actually different. The second factor right here, this whole thing right here, this is actually not a circle. And that's because of the second part of the equation. Here, the difference between this guy and what I just circled is that the first factor, yes, again, that is a complete circle because it's in the form of x squared plus y squared is equal to 25. But the second factor, this is only going to be the upper half of the circle because on the right-hand side over here where you notice the square root of 4 minus x squared, that can only be positive. So that tells me I can't actually have the lower part of the circle, but instead it's the upper half of the circle. So that is going to be something that's a little bit interesting. Okay, so here, let me just go ahead and graph what we have right now. So then that way you have like an idea as to what's happening. So here, let me go ahead and draw my axes. Okay, so let's see. Here's the y-axis, here's the x-axis. So first, we're going to go ahead and go out to 5. We're going to go out to 5 over here. We're going to go out to negative 5 over here. And then we're going to go down all the way to negative 5 as well. The first graph, as we said, is going to be a circle. And forgive me if I butchered it. There's going to be my circle, okay, with centered at 0, 0, and the radius of 5. Okay, so that's going to be my first factor. My second factor, again, is supposed to be a circle with radius of 2 with a center located at 0, negative 2. So here's 0, negative 2. And normally, this is what it would look like. Okay, this is what it would look like. But according to what we just said, because of the form y plus 2 is equal to the square root of, that tells me it's just the upper half of the circle. So that means for my graph over here, I actually don't have this part, and I don't have this part. Then I don't have this part, and I don't have this part. Okay, so a little strange, but hopefully you understood why then. Okay, now let's go ahead and look at the third factor, and let's see if we can graph that. We're going to go ahead and set that equal to 0 as well. So x minus 3 quantity squared plus y minus 3 quantity squared is equal to 0. Now, this is going to be more of a translation thing. We have to kind of like figure out what's happening here. We have two numbers that when added together, we have two numbers that are going to be squared, and then when added together is equal to 0. Normally, that's not really even possible because anything squared is always going to be non-negative. Anything squared that's always going to be non-negative. So the sum of anything squared, that is going to give me something that's non-negative also. The only time that this is going to work out is when you have x is equal to 3 and y is equal to 3. Another way of looking at it is that this is basically also a circle, okay, with a radius of 0, okay, and your center is located at x equals to 3 and negative 3. And let me just go ahead and change that right here. Okay, so let's see. So 3, 3. Okay. So for the graph, we have to basically graph the point 3, 3. And I think we can finally look at the last factor and think about exactly the same way. Noticing that we have x plus 3 squared and then we have y minus 3 squared. My guess is that this is going to be just a single point, which is also a circle, but located at x equals to negative 3 and y is equal to 3. So the last two factor turns out to be just 2 points, 3, 3 and negative 3, 3. So then that is going to be located right here, and that's going to be located right there. So your final graph is going to be this, I guess, sad face then as a result. All right, so that's going to put an end to all of this. Let's see how this works out. And I know this is exactly not the length that I wanted, but I'm just trying to figure things out on my own also as we go along. So please forgive me for that. All right, so have a good one.